Now, the old me would have looked at this and would have been like, so what? It's still hot. It's the sun. It's going to be hot. It don't matter what color it is. It's hot. It's going to be hot. But the new me is like, you might need to look into this, bro. You might need to see what they talking about in this video. So that's what I'm going to do. This video is titled, man, what if the sun was in other colors? All right, so if you're new to the channel, hit that subscribe button, join the fam. Let's see what they talking about.
Now, did you know that our sun is actually green?
No.
Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious. Can't you tell?
No.
In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets.
Leprechauns with pots of gold that want me shilling. That's where rainbows come from.
Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere.
Wow.
Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad.
Like a horror scene, running around in a horror scene all day.
Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But
I knew it wasn't going to be good when he said one day it will turn red.
It's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white. But technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it like by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference.
So,
And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much.
and then you have to worry about, man, if the sun turned black, it'd be a purge outbreak. Everybody be running around trying to purge.
Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars. And still, our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, right, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit.
Wow.
The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees.
And it's nothing we could do. Nothing. We're at the mercy of the sun, just like that.
Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people.
Or y'all be running to the drugstores trying to get all the melatonin you can get, bro. Like, I hear melatonin so much now, it ain't even funny, man. Even the little kids be talking about melatonin. Mom, you got some melatonin so I can go to sleep. I'm like, what?
But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes? So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years.
For us, the solar storms, we got to be worried about that we talked about in the other video. So not only do we got that, but this to worry about as well. Good, great.
Early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the sun. High-speed electromagnetic plasma gas from the sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the sun, but they aren't dark. They're just not as bright as the surface of the sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the sun associated with sunspots. As the superhot plasma gas on the sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth. while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface.
I'm gonna say that next time I'm drinking a Corona. Be like, yo, comes from the Latin word meaning crown. Have one, would you?
For crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis.
Why would y'all name it Nemesis of all things?
They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So, they turned to the stars to find out what the reason might be. And then, they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's gonna be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets...
See, that's why it's important to know what's out there in space. This thing is 9 trillion miles, 1.5 light years or whatever it was, the number was, and it's still affecting us. So imagine what else is out there affecting us. You know what I'm saying? This stuff is important.
form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a...
This can't be good. Y'all heard that? Bro, it is coming down here. We're under tornado watch as well. But anyway, back to this. This can't be good. It breaking up into 3 stars hitting us from different angles. Now we're having to monitor 3 of them that could send solar storms to our way 3 different ways. Like, yeah, not good.
Very detailed simulation. No, probably even a dozen simulations to make this thing work. Because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold.
So imagine that, not y'all, because y'all looking at the video, obviously, so you'll continue to pay attention to what's going on with NASA and different things as they alert us. But imagine the people who don't care to know that we just floating out here. We just floating, and we could possibly just collide into something at any moment.
What a sad and poetic end. In general, none of these outcomes sounds very fun.
No.
Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to, because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure.
No need.
But theoretically, we could survive in a simple binary star system.
Small
For example,
chance.
in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Listen, man.
55 Cancri
I can't never stop it in time. Listen, man, you went from drawing the sun in the top right-hand corner of your sheet of paper to now knowing so much about the sun, plus the possibility of it breaking off and creating other little suns. You know what I mean? It's juniors. You know what I mean? Like, this is crazy, bro. How do we, like, I often say, man, what was I doing before this information? Just wandering around aimlessly with no knowledge. It's crazy now. Does it invoke a little bit of fear? Absolutely. But I still rather have the knowledge. Y'all get at me in the comment section, man. Let me know what you thought of this video and stick around and stay tuned. Till next one, I'm gone. Peace.